Now this one, we have to take it all the way, because now they're asking for us to set up the limit definition. We have to actually solve for the derivative using the limit definition. Okay, so the first thing we have to do is find our x plus h. Okay, so we know we just replace every x with x plus h. Uh-oh. Is equal to negative x plus h squared minus 2 x plus h plus 3. Okay. Now this is where we have to actually factor it out. So we know that x plus h squared is equal to x squared plus 2xh plus h squared if you separate it and FOIL it out. Okay. So we know that's equal to negative x squared plus 2xh plus h squared. If we distribute that negative 2, it'll be minus 2x minus 2h plus 3. So we can also distribute this negative 1. So we know our s of x plus h is going to equal negative x squared minus 2xh minus h squared minus 2x minus 2h plus 3. Okay, so we have that part. Okay, second step, we already know what our s of x is. So we get it and we just plug it into our formula. Same way we did before. So since our s of x is equal to negative x squared minus 2x plus 3, we just plug it in. So s prime of x is going to equal the limit as h approaches 0 of s of x plus h minus s of x all over h. Okay. So if we plug that in, it's going to equal the limit as h approaches 0 of s of x plus h is negative x squared minus 2xh minus h squared minus 2x minus, I may not have enough room. Something kept gnawing at me to start on the next line. Especially since these tend to get a little bit long. H approaches 0, negative x squared minus 2xh minus h squared minus 2x minus 2h plus 3 minus your s of x, which is negative x squared minus 2x plus 3 all over h. Okay. Now once you get, oh yes.
The h is always going to 0, correct?
Yes. Yeah. Okay. Now once you get rid of all your parentheses, you should start to see things cancel out. So you have your limit as h approaches 0. Here, this is all positive, so you can just drop the parentheses there. So you have negative x squared minus 2xh minus h squared minus 2x minus 2h plus 3. And for this one, if you distribute the negative, negative times negative is positive, so you have plus x squared plus 2x minus 3 all over h. Okay. And here's where things should start canceling out. And so you have negative x squared plus x squared. You have minus 2x plus 2x. You have plus 3 minus 3. Okay, so you have equal to the limit as h approaches 0 of negative 2xh minus h squared minus 2h. Everything else disappeared all over h. Okay, so this step here, you're going to cancel out. Terms. And this step here, once you get here, you're going to factor out the h so you can get rid of the 1 in the denominator. Okay, so if you factor out an h from each of those terms in the numerator, it's equal to the limit as h approaches 0. Factor out that h, you have negative 2x minus h minus 2 all over h. Now you can cancel out that h, which gives you the limit. I'll put it underneath it. As h approaches 0 of negative 2x minus h minus 2. And now you can plug in the h equals 0 without having a denominator that's causing it to be undefined. Okay, so if you plug in your h equals 0, you have negative 2x minus 2. And that's your final answer. So direct substitution of h equals 0.
The negative 2x minus 2, that's h.
Oh no, your h is just whatever h is left after you cancel out. That's the one you're going to plug in. So once you plug in the h here, you don't, or whatever's left will be your limit definition or your derivative. Okay, so that's your definition of a derivative. Well, using the limit definition. All right. Yes.
Okay, so I got up to everything except how did we find out? Because I know the whole entire x plus h ordeal was, but how did negative x squared and negative? Oh my gosh, yeah. How did that become negative? The negative x and negative h squared.
Negative x and negative h squared. Which one are you on?
Let's go for the top.
Top one right here.
I know that you have negative x, which is from the s of x plus h, which is x plus h squared, but should that, I think I'm just overthinking this.
Okay, so here we just substituted our negative x with, negative x squared with negative x plus h squared. Then we FOIL that out, and all we did here was distribute the negative 2. So once we just have that one function there.
Oh, so it still is negative. Oh.
Yep, so the negative still stayed on the outside.
Gotcha.
Yeah.
I thought it was like integrated.
Oh yeah, if it would have been, let's say instead of negative x squared, then it would have became just positive.
Okay.
Yeah.
Yeah.
Yep, that negative on the outside with no parentheses makes a big difference. Okay. Oh. Okay. Any other questions on this one? All right. Let's do it right here. Okay. Oh no, the next example will show you why. Okay. Now, before we go to the next one, we're going to review Pascal's triangle. Okay, because it actually does come in handy. Is anyone familiar with Pascal's triangle? All right, so it starts off like this. You just start off with a 1, and then you branch out from that 1 to a 1 on each side. Okay. Then you branch out again to a 1 on the end, but you add those two together. And you put a 1 on the end. So you're always going to have a 1 on the outside. Okay. So you have your 1. So you add those two together, which gives you 3. You add those two together, which gives you 3. And you put a 1 up there again. Okay. And you just keep doing that over and over and over. Okay. So you start with a 1. Add these two together, you get 4. Add these two together, you get 6. Add these two together, you get 4. And you put a 1 on the end. Okay, so I'll do one more level. Okay, so you put a 1, add those two together, you get 5. Add those two together, you get 10. Those two together, you get 10. Those two together, you get 5. And another 1. Okay, and it just keeps on going like that forever and ever and ever. Okay. Now what makes this really handy is that if you get that 1, let's say you have a plus b, that's the power of 0. And I'll show you how it all kind of falls into place. If you have these two 1s, that's a plus b to the first power. This one here is a plus b squared. And a plus b squared, well, we'll start with this one. You notice here, anything to the power of 0 is just 1. A plus b to the first power is just a plus b. Or you can say 1a plus 1b. Straighten it up a little bit. Okay. So a plus b squared, if you separate it and do the FOIL method, you have a squared plus 2ab plus b squared to the 1, 2, 1, 1, 2, 1. Okay, so a plus b to the third power is a to the third plus 3a squared b plus 3ab squared plus b squared. Okay, and it keeps on going and going and going like that. Okay, so if we were to do, I don't think I'd have enough room for the fourth one. Okay, so let's say, for example, you have a plus b to the fourth power. You're going to use this 1, 4, 6, 4, 1. And let me make sure I have a, yep, I'll do that one. So let's say you have a to the fourth, b to the 0, plus 4 times a to the third, b to the first, plus 6 times a squared, b squared, plus 4 ab to the third, plus 1, I guess you can put the 1s there, just space holders kind of, a to the 0, b to the fourth. Okay, so here your a is going to start at your exponent, and it's going to go down each term. The b is going to start at 0 at the first term, and it's going to go up each term after that. So if you notice here, a to the fourth, a to the third, a squared, a to the first, a to the 0, which is just 1. Then you have b to the 0, b to the first, b to the second, b to the third, and b to the fourth, and you get all of your coefficients there. So instead of multiplying a plus b times a plus b times a plus b times a plus b, doing the FOIL method twice, and then you get 2 trinomials, and you try to distribute. It's just a whole lot of work. This cuts down on a lot of it. Okay, so the a exponent. Oh, actually, I should simplify this before I write the explanation down. Okay, so this ends up equaling a to the 4th times 1 is just a to the 4th, plus 4 a to the 3rd b, plus 6 a squared b squared, plus 4 ab to the 3rd. 1 times b to the 4th is just b to the 4th. Okay, so this is where we know that let me stretch that a little further below the answer. Okay, so the a exponent goes up 1 degree per term, while the b exponent goes down 1 degree. Uh-oh. Per term. Okay, and that's if you're going from left to right. Oh, bring that up some.
Is this one going right to left?
Nope, left to right. So the a is going to go down from left to right,
Okay.
and the b is going to go up from left to right.
Okay.
Always starting at 0 and ending at 0.
Yeah, exactly. Okay. That's why the first term's always just a to the 3rd, a squared, because you really multiplying it by b to the 0 power, which is just 1. Okay. So if we used our x plus h to the 4th power, okay, using what we have there, we know we're going to have x to the 4th. Actually, we can even use that and just substitute x for a and h for b. X to the 4th plus 4 x to the 3rd h plus 6 x squared h squared plus 4 x h to the 3rd plus h to the 4th. All right. So any questions on that one?
If there was, let's say it was like 2x plus h, would that affect the number that would come before the x at all? When it will,
If the 2 is,
yeah, like can we
Like
still do the
out front?
Pascal triangle if it's if there's like a exponent or something in front of the variable?
oh yeah, you just have to remember to add it. So if you had x plus, let's say a plus 2b.
Okay.
So instead of putting b to the 0, it would be 2b to the 0 plus 2b to the first, 2b to the second, 2b. Then you combine your numbers.
I got you.
Yeah.
Thank you.
So you can do it with any 2 terms. All right. Any other questions on this one? All right. So we brought this one up because our next example will use our x plus h to the fourth. So, gets a little bit long, so I'd start with a fresh sheet if I were you. Okay. Sure, you want to just go right in. Okay. Yeah, I should be able to do it in 10 minutes. Okay, so for example, let's say if we're given r of x is equal to 3x to the fourth plus 4x squared plus 7x plus 4, find r prime of x using the definition of a derivative. All right, so first thing you want to do is find your r of x plus h. Oops. Okay, so that means your r of x plus h is going to equal 3 times x plus h to the fourth plus 4 x plus h squared plus 7 x plus h plus 4. Okay, so just to avoid confusion, we know that our x plus h to the fourth is going to equal x to the fourth. Oh, make sure I get a little more room. Plus 4x to the third h plus 6 x squared h squared plus 4x h to the third plus h to the fourth. Barely made it. And our x plus
That's
h.
just the 3 x plus h to the fourth. That's just that one part.
Hmm?
The one you just did on the right side?
Yeah.
That just goes to the 3 x plus h. to the
Oh yeah,
fourth.
yep, that just goes for that. So we're going to replace that with all of that. And x plus h squared is x squared plus 2xh plus h squared. All right, so now we replace all of that. Okay, so that's going to equal 3 times x plus h to the fourth, so that's x to the fourth, plus 4x to the third, h. I don't know if I'm going to have enough room. I'll move it over a little bit more. There's 3 x to the fourth plus 4 x to the third h plus 6 x squared h squared plus 4 x h to the third plus h to the fourth plus 4 times x plus h squared. Oh, forgot to close that up. X squared plus 2xh plus h squared plus 7x plus h plus 4. Probably should have had that up a little further. Okay, so if we distribute our 3 and our 4s and our 7s, our r of x plus h ends up equaling 3x to the fourth plus 4 plus 12 x to the third h plus 18x squared h squared plus 12xh to the third plus 3h to the fourth plus 4x squared plus 8xh plus 4h squared plus 7x plus 7h plus 4. See, I always get really greedy up at the beginning and then have to squeeze it towards the end. Okay, so we have our r of x plus h. Okay, so your second step, we already know what our r of x is. Let me move that down just a hair. Since we know that r of x is equal to 3x to the fourth plus 4x squared plus 7x plus 4, we just plug it into our formula.
That for x?
Hmm?
That's for x?
Oh no, the limit definition formula. Yeah. Okay. So that means we have our r prime of x equals the limit of r of x plus h minus r of x all over h as h approaches 0. Okay, which means it's going to equal, move this over a little bit, the limit as h approaches 0, r of x plus h is all of this up here. So that's 3x to the fourth plus 12x to the third h plus 18x squared h squared plus 12xh to the third plus 3h to the fourth plus 4x squared plus, oh, where did I leave off? 8xy, xh, I don't know why I said y, plus 4h squared plus 7x plus 7h plus 4. Okay. Once again, I should have moved that over a little more. Minus, where is it?